Science data processor is absolutely critical to the workings of the SKA telescopes. So SKA is going to be delivering petabytes of data each day. And we need something which is able to deal with that huge volume of data and process it into something manageable from which astronomers can do the science that they want to do. So France has got huge expertise in its research institutes and its industry in high-performance computing. And in particular, Eviden, who we are signing a contract with today, have a really strong capability and legacy.
In France, there is a big tradition of signal processing, data processing, and radio astronomy development techniques.
So this is an opportunity for the French computing industry through Eviden to demonstrate its capabilities in a high-profile international project.
So really the first challenge is how we transform this data into knowledge, into data that can be consumed by scientists. The second one is that the telescope is being built step by step. So we need to build an architecture that will continue to deliver high-performance computing, high-performance data management with the scalability request from the telescopes.
Before SKAO, the astronomers were receiving the data before the SDP phase. So they needed to be radio astronomers, expert in signal processing for radio data in order to get scientific information out of the data. Now, thanks to the SDP, the SKAO will be much more used also by a wide community. And this is important for many reasons, including for opening as much as possible the discovery space and use SKA together with other instruments, other astronomical facilities.
It's really very, very important for us to feed and co-design with scientists this machine.
So the scientific community can really improve the way in which data are reduced and analyzed by collaborating with industry, and at the same time industry can get a very important new use case and challenges in the domain of exascale architectural computing and in the domain of energy saving for the use of supercomputers. So it's a win-win collaboration.
So these projects really show that very ambitious fundamental research can push technology to its limit and benefit society as a whole.
For the last 10 years, we massively invested into technologies to cool and be super energy efficient when we compute. That was a big requirement of this system, and we will be able to be fully compliant and deliver one of the most energy efficient system in the world in terms of HPC.
So the initial deployments for the science data processor will turn up in 2026, just ahead of the first science verification of observations that will take place in 2027. And that's important because that's the first time that the first community science with SKA is going to be done.
Okay, now let's dream. Let's look forward. Let's anticipate the first scientific result from the SKA telescopes. Let's also enjoy the perspective of having this magnificent data available to the global research community